So our goal is to get the variable by itself. You're going to hear me say that so many times. Remember, when we take notes, you write down what I write down on the board, and you engage your mind and you listen. Because if you're just writing it down, you're not getting the full effect. Inverse operations are just a fancy way to say doing the opposite thing. Inverse means opposite. So if you want to add that, inverse means opposite. So we're going to talk about what our inverse operations are. Okay, class. I know you can answer this as a class. What's the opposite of addition? Subtraction. Adding, right? The opposite of adding is subtracting. So I'm going to draw a little line there. The opposite of addition is subtraction. So then what's the opposite of multiplication? Division. So those two lines, I guess I should do it in a different color. Those two lines that I've drawn, those are our inverses. If you want to undo multiplication, then you have to do the opposite and divide. If you want to undo addition, you have to do the opposite, the inverse, and subtract. Y'all know this. Okay. So solve one-step equations. Do the inverse to both sides of the equal sign. That's super important. We're going to solve using subtraction. What's happening to your variable right here? Would you please tell your neighbor what operation is that right now? Addition. Yeah, it's addition. Okay. So you're going to see me draw a balancing line a lot of times. So I'm going to draw a line down my equal sign. That tells me what I do to one side I have to do to the other. Where I see plus 5, if I want to get rid of the plus 5 to get the w by itself, then I have to do the opposite, which is subtract. Can I take candy away from this side and not the other? No. No, not fair. Do it to both sides. Show the work for both sides. It needs to look like this. If it doesn't, then I can't give you partial credit. And I also don't know what you're doing. Okay, class, what's 5 minus 5? 0. So this would,
We did this in 6th grade.
Yep. This would go away because it's 0. 5 minus 5 is 0, so you'd have w plus 0, but you don't need to write that. So I'm going to draw another line because I have a new equation now. Use your number line if you need to. I want to know what 13 minus 5 is. You sure?
Yes.
Okay, yeah. So w would be equal to 8 because the plus 5 is gone. We took it away with subtraction, and our final answer is 8. I'm going to usually box my answer like that so I know what my final answer is. This is the kind of work I expect to see. Nice, neat, I can follow what you're doing. You showed your work. Sorry? Addition. Okay, let me tell you why it's addition. It's not because there's a plus sign in between. It's because this 6 is positive. That's why it's addition. Because the 6 is positive and it's separated. So to undo addition, I subtract. So I'm going to subtract 6 from both sides. What's 6 minus 6?
0.
0. So it dies, right? So I have a, let's see, on the left side I have a positive d. So I'm just going to write d. 5 minus 6, use your number line. You go 5, down 6, now I'm in debt $1. -1. Let's see, Desavion, what operation do you see here? How is this 11 related to the x? It's being subtracted. Class, how do I undo subtraction?
Addition.
Addition. The opposite of subtraction is addition. So if I want to get rid of the minus 11, I have to add. So I'm going to draw a balancing line. And then add 11 to both sides. Show the work. -11 plus 11 is 0. So that's incorrect right now. So the -11 plus 11 goes to 0, so you get rid of it. You're left with x is equal to 31. You have a -1 plus your variable. This is subtraction because the 1 is negative. Some of you are going to say, well, it's addition because there's a plus sign in between. No, 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 no. Look at what's in front of the number. In front of the number, you see a minus sign, so it's being subtracted. What's the opposite of subtraction? Addition. So you have to draw your balancing line and add 1 to both sides. You're taking the numbers away from the variable. When I do -1 plus 1, Connor, what do I get when I do -1 plus 1? I get 0. It dies, right? So cross it out if you want. So the only thing you should have left now is a positive p is equal to -3 plus 1 would be -2. -2. We talked about this last week. When you see a variable right next to a number, it's multiplication. So this is 2 times w is equal to 48. So when you see a number right next to a variable, that's multiplication. How do I get rid of multiplication? Division, do the opposite. So when I divide, you're going to see me do this fraction bar like that. I'm dividing by 2 on both sides. That's what that means. The reason this works, let's talk about it. What's 2 divided by 2? 1. So you end up with 1w. So you got 1w by itself. So you can cross that out. So you only have 1w left, which means the variable is now by itself. 48 divided by 2 is 24. If you want to write out the division sign, that's okay. I would encourage you to try and get comfortable with the fraction bar because I like it better, and it's just what you're going to see moving forward. I looked at Javon's paper and he did something really good. If you notice on this one, the variable's on the right-hand side. For some of you, you get like, whoa, I don't know what to do with that. You can do what Javon did and just flip it around. It's the same thing to say 9p equals 27. If that helps you, great. Okay, now I talked to Brandy. Brandy, what number am I trying to get rid of? And how do I get rid of it? Right, because it's being multiplied. So divide by 9 on both sides. And the 9 dies because 9 divided by 9 is 1. So you're left with p is equal to 3. About when you see this bar, it means division. So you have x being divided by 3. This is at the bottom. So what's the opposite of division? So to get rid of division, we multiply by that number on both sides. It's being divided by 3. I'll continue when you're ready. It's being divided by 3, so I'm going to show that by get rid of it by multiplying by 3 on both sides. So remember that little dot? That means multiplication. You multiply by 3 on the top of the fraction. So on this left-hand side, you get 3 divided by 3, which is 1. So it dies, right? It goes to a 1, and so you can cross it out and simplify the fraction. Let's see, I know that 12 times 3 is 36. So x is equal to 36. Explain in your own words how I get the x by itself.
You divide 5 by 5.
Hold on. I undo division. So what do I have to do on both sides? Times by 5 on both sides of the equation. When you do that, these 5s die on the left-hand side, but you're left with x is equal to 75. You multiply that up. Let's go ahead and do our first example together. You're going to do the second one on your own. Right now we're multiplying by 2/5. What is the flip of 2/5? Would someone please tell me? Juwan, what's the flip of 2/5? 5/2, right? These are just, it's an inverse, right? It's the opposite. Flip it upside down. I'm going to multiply by that flip on the left side. Can I give candy to one side of the room and not the other?
Yep.
You can, but it wouldn't be very fair. Not if you're both being good. You need to multiply by that on both sides. I know you guys don't love fractions. You're wrong. Okay, if you look at this one on the left-hand side, if you actually multiply this out, you would get, look what you get. 10/10, which is a whole number, which is 1, right? So you got it to go to 1, and so what you can do is just cross it out. That's why that works. On your right-hand side, though, it's not going to go to 1. You're going to get an answer. 10 is not a fraction right now. How can I make it a fraction? Now to get your final answer, multiply straight across, right? So 10 times 5 would get me 50 on the top. And 2 times 1 is 2.
So m equals 50.
But this is not as simplified as it could be. 50 divided by 2 is actually 25. So your final answer should be m is equal to 25. Please check your work with mine, then answer your essential question in your summary.